Hi, my name is David G, and I work for the Cloud Ready Data Center team inside Juniper Networks, and this is an update video for JTAF 1.5. We've got news, however. October 2021, we signed the HashiCorp Alliance's partnership agreement. This is something I am very personally proud of, and it should hopefully signal to joint customers of HashiCorp and Juniper Networks that we intend to extend the control point from Terraform, from cloud, from on-premises cloud infrastructure, all the way down to network elements running Junos, whether that be physical or virtual. This is a really big deal for us. JTAF is maturing pretty rapidly, so 1.5 we now handle lots more edge cases around Yang, and it's beginning to get quite complex in terms of how it handles those models. More information, you can go to github.com/juniper/junos-terraform.git, and in this short video I'm going to take you through building a provider using JTAF 1.5. So in this environment, I've got a working directory, which is /var/temp/JTAF demo, and a number of files. We've got the Junos-Terraform directory, which is literally just the Git, a Git clone. And what I've done in the samples directory from Junos Terraform, I've taken the contents of the Terraform template module and I've copied them to the working directory. So we have a config file, we have the module, we have the Terraform providers directory, the XPath example file, and the Yang files. So the module contains a working Terraform module. We have the Terraform providers directory, which is where the Go code, when it's generated by JTAF, will reside and where we can build the provider. We have the XPath example, which is an XML file containing our selections, what we'd like to include in the Terraform provider that we're going to generate, and I'll show you how to basically find that information. We've also got the Yang files, and what I've done for this example, and this is true for the samples directory inside the Junos Terraform directory, the Yang files are included in this. Now the Yang files are actually for 20.3 R1 targeted platforms. We're going to build a provider and actually run it against a VSRX 20.3 R21 if I'm not mistaken. And everything is ready to go, so we can go from zero to provider hopefully very, very quickly. You will need Go install, and I've just noticed actually the VM is already active in the background. So what I'm going to do, I'm just going to reset this, deactivate the VM, and go. Right, so next step, let's just take a quick look at the config file. The config file contains 5 key bits of information. Please double check to make sure you've got these absolutely correct, else you will see some errors. The Yang files directory contains the Yang files, and also what will happen is the JTAF is split into 2 parts, the process Yang part and a process providers part. It's 2 tools. The first part will take the Yang files inside that Yang file directory, wherever it may be, and it will create yin, and it will also create text equivalent XPaths of those yins. The provider directory is where the auto-generated code goes. That's from the second part of JTAF, so the process providers part. The XPath is used for the second part. So the process providers part, we use that XPath file, and that's how it knows what code to generate. File type text. We could literally just generate yin, but actually we need both because the indexes are very, very helpful. They give us a very easy way to identify what we want to include in the providers and copy them into this XPath example file right here. And then we've got the provider name. Now this could be QFX, it could be MX. In our instance, we're going to call the provider VSRX. You might notice there's not a version number. Versioning is taken care of in the default directory system that Terraform looks for, and what we have on my system, and I'll just show you this, is we've got a Terraform directory, which is a default location, which is terraform.d, and this is what the directory structure looks like. So we have /plugins, /Juniper, /providers, /Junos SRX, and you'll notice there's a 1.1 version and there's a 20320101. Now, ignore the 1.1. This is my testing and it's no good to you. So what we're doing is this is a semantically versioned controlled system. So we have the major version of 20, minor version of 32, and it's actually 20.3 R2. We can't put an R in here. It's only accepts digits. numbers or integers, and we have 0.1, which is the patch version for Junos, and we have 0.1 after that, which is our version for the provider. When this finally goes live and we have publicly available providers, these last two digits will signify what build version the provider is for the particular version of Junos that you're running. And the platform ultimately here is a VSRX platform running software 20.3 R2.01 with build 01 of a provider. This is a private build, so this is not going to be online. You're not going to find this anywhere else. This is literally what we're going to build right here in this example. The next step then is to I'll show you the YANG files, just to show you that they're in there. You'll actually see .text.yin now. I'm just going to show you the contents of the YANG files directory. When you do a git clone, only the YANG files will be included. For the name, basically, of saving time, or in the name of saving time, and running this video as a one-time pass, I've already ran the first step. However, I'll show you what it takes to run the first step. You'll have to make a cup of coffee or a cup of tea or whatever your favorite drink is whilst you wait for the YANG files to be processed. So if I show you the contents of the YANG files right now, you'll notice there's text files, which is the XPath text files. We've got the yin files, which is an XML version of the YANG, and we've got the original YANG files. But what I'll do is I'll just show you the original set of YANG files that came pre-packaged with in the samples directory. Those are the YANG files that we're going to be working with. Only a handful of them really at that. Just if you see any trickery, this is the only trick I pulled just to speed things up. Right, next step is for me to show you some basic stuff. There is some key paradigms when it comes to working with Terraform and with Junos. And to illustrate this, I'm just going to show you the contents of the model pretty quickly. This is the top level Terraform file in the module that we're going to be working with, and there's some points that you're going to need to know. So one of them is we're importing the provider, or making Terraform aware of the provider. So this is the directory that we've just looked at. This is the version of provider that we're going to be looking for. This is the provider input for the Junos VSRX configuration. So this is the provider name, this is the input for that particular provider, and this is the configuration information. SSH key does work. You might want to load this up via some other means. For this demo though, however, how we've got this right now is more than suitable. Then we have two resources. Now these are really important. Think of this as bookending a pile of resources. So we have a module which contains everything that we want to configure on Junos. Each resource that we configure on Junos actually is a configuration group on Junos. So it's a resource locally for Terraform. It turns into a configuration group on Junos remotely. So the module contains everything that we're going to commit and build and push. And then we have these two resources. One of them is a commit and one's a destroy commit. Now what happens if you've seen this depends on keyword, the module depends on the destroy commit, and then commit depends on the module. You can see these relationships right here. So in the order of execution, what happens is there's a graph. We have a commit, the module, which contains a horizontal list of resources, and then we have a destroy commit. The destroy commit is created first. It doesn't actually create anything though. As you know, a commit is just an RPC against the system. It's a CLI command which turns into an RPC call underneath. We're doing the same thing over netconf. So the destroy commit is created. There's no creation. Some local state actually is created, but beyond that, there's nothing else. Then all of the resources contained in the module, those are created. Then the top level commit, once that module is satisfied, once Terraform is satisfied that everything in that module is created, the last commit, which is dependent on the module, is issued against Junos, and that commit actually does something. It issues a proper commit. So again, it's a bookended thing. We have a top level commit, we have a destroy commit, and we have the modules. So when you do a Terraform destroy, what happens is the top level commit is destroyed. Again, nothing happens. The local state is destroyed, but nothing on Junos happens. All of the individual resources are deleted. So that's each configuration group on Junos is deleted one by one. Note, no commits at this point. Once all of those resources have been deleted, including the equivalent action on Junos, which is to delete each of the configuration groups, then the destroy commit is executed, and a destroy commit actually is a proper transactional commit, even though it's called on the delete call. And that's how we handle the commit-based system in the intersection of the lifecycle of Terraform and the lifecycle of Junos. There's an edge case. When we deal with updates, and if we update either local state or remote state and we want to do a reconciliation task with Terraform, we have to taint the commit resource. And when we have to taint it, it's this one here, Junos vsrx commit, and it will be dot commit -main. And what that does, that tells Terraform after an update to rerun the top level commit. You don't have to do the same for the destroy commit, but you do have to do it for the top level commit. That's really important. If you only remember that from this video, then that's probably going to be enough for you. So that's a module. Let's just take a very quick look at the contents of the resources. These are all of the individual resources that we're going to create in configuration groups on Junos. Now, these are fairly straightforward. There's no implicit relationships, and what I mean by that, there's no $ something or other. These are all independent resources. We could add some ordering to these. We could use something called a depends on keyword, and we could actually force a dependency tree, or we could also do things like include a $ and reference another resource's key value, which would also create an implicit relationship. There's nothing like that here. There are some things of interest, however. This particular resource uses enumerated data types inside the data structure in Yang. And what that actually looks like is something called a choice ident. And there's three keys. You have the top level key, you have something called a choice ident, and a choice value. Not all enumerated types accept values. So we have keywords like all longer and longer. And there are lots and lots of different enumerated types. And the way to view some of these ones that don't take any value is just to feed it a single white space. You can't not include the single white space. It's the only way to turn this particular enumerated type on. Think of it as a switch, and providing you've included that white space, the or longer switch works at the end of a statement like a filter. And if you think about this as a CLI command, it's kind of like setting the full CLI and then putting an or longer on the end. We have to think about this in terms of welding together how Terraform sees the world and how we execute XML over netconf against the Junos instance. And then we've got oddities like for accept. You don't have to do that. You just use a pair of closed quotes. Now, if this is another keyword like through, instead of a single white space, actually you just include a string value for the prefix that you want to include. So in this instance, if we were doing a through, we might have the address as 10/8 and then through equals 10/24. That would be absolutely valid. And then for other enumerated types, we might just be able to turn them on with a single white space. So like I said, there are some oddities with how we have to process these things, but it does indeed work. So they're the resources that we're going to be building. Note at the top, we're including the provider again. We don't have to include anything like configuration information for the provider. That's being passed through from the top, but we do have to just make sure we're calling the right provider from Terraform. So that's the module. The next step from here would actually be to generate the yin files and generate the XPath files. So again, the XPath is just a list of XPaths for every single data structure inside that yin file. So what I'm going to do now is I'm going to go to Junos Terraform command process Yang. Now I'm going to build the process Yang binary. And now the main.go is a top level code. There's some other files inside the data structure. And the process Yang is now statically, well, it's a compiled binary written in Go. There's one thing we need to do, however, and that is we need a VM. And the reason is the process Yang code runs Pyang, and Pyang does the conversion from Yang to Yin. And then also then the process Yang code generates the XPath expressions. So we need to create a VM. I'm just going to call it VM because I'm old school or lazy, whichever one you want to refer to. And then I'm going to activate that VM. Bin activate. And then I'm going to install Pyang. And we'll just do a quick version check on Pyang. And 252, yeah, there we go. Right, so now when we do this, process yang, it takes one input switch, which is a -config, and we have to point it in the direction of the config file, which is var temp, JTAF demo, and JTAF config, which is just this file here. We already know what's in it. We've got the 5 keys. Now, I'm not going to run this. And I'm not going to run it because we've already got all the files that we need, and if I start messing around, chances are I'm likely to break one or more of the yin files or the text files. They've all been pre-processed, but what you do now, hit return, and then the first point or the first process within JTAF, the process yang aspect, kicks in and works. Now, we've already done this. It can take a few minutes depending on how many yang files that you've got to be processed. If it's 1 or 2, you could probably just sit there and wait. If it's 10, go make yourself a drink. Right, let's just pretend we've done all that and we've got all the files. I know we've got the files, but we haven't just sat there for ages watching them process. So we're going to go to the process providers, and I'll also just deactivate the VM as well. So process providers, go build. We'll have the newly built binary there as well. Now process providers, exactly the same usage pattern, -config, feed it the config file. Now what process providers is going to do, it's going to generate Go code from the XPath expressions. So I'm going to run this and I'll go back, show you the XPath expressions, and I'll show you some of the code that's been generated. This is normally a very quick activity. Now you notice here there's a number of potential issues, and I bet you any money this is to do with the XPath not found, XPath not found for licensing. Now, this happens from time to time. It doesn't actually mean it's a broken issue. I'm not using anything to do with licensing resources inside of this. All it means is a mismatch between the list of XPaths and what's been opened up and read by the process provider source code. And I say potential issues because it might not be. If you run into an issue and it's been identified here, please include the platform that you're working on, the software version, the operating system that you're running JTAF with, the Yang models, the XPath expressions, include all those things in a GitHub issue, and we'll try and repeat the problem, issue a fix and a patch, and we'll respond accordingly. We do have, however, 49 XPaths that have been processed. We've also automatically copied across some other Go files, so that's a commit resource, a destroy commit resource, the main.go and config.go. One of the files that would have been created would be a provider.go, and the provider.go is really the top level index into all of the other source code. And it will also generate the Go module for us, which means all we have to do is issue a Go build. So I'm going to go back up now. Where am I? Back up to the working directory and just make sure we've got all of our files. I'm going to drop into the Terraform providers directory, and in here now we'll have all of the generated Go files, and you can see here the timestamp 1502. It's just literally just gone to 1503. We've got the files that were copied across, the destroys, the destroy commit and the main top level commit. We've also got the provider.go file, which is a freshly generated file. Main.go and config.go are copied across. We've got the Go mod as well, which helps us just build this thing very, very quickly. So I am just going to do a Go build. Go build will actually build the Terraform provider. This shouldn't take very long at all. And then there we have at the bottom, look, Terraform provider -Junos -SRX, which is kind of exciting. What I'm going to do as well, I'm going to show you the input to, the contents of the provider.go file. Again, this is where all of your resource references are contained. So for instance, here we have the Junos -VSRX _ system root _ authentication encrypted password. Now, each of these refers to one resource, and each resource has 4 functions: a create, read, and update function. So what we're going to do, just for the hell of it, I'm going to look at the source code for this. Junos -VSRX policy, options policy, statement term, from root, filter address. This calls the function here, but I'm not interested in that. What I want to do is show you, so this is the Terraform resource name, and then I'm going to show you the source code of what that looks like. So we're going to do cat resource, is it policy term from, and then it's from filter address. Now, this is where things get interesting. So what we have is we have 4 functions that are generated. You can see we're looking at the create one right now. And what the create one does, it pulls information from local Terraform state. And actually this is from the HCL. So get these keys if they exist. And in here, these are all the enumerated data types that we spoke about earlier on. So in here, you might see longer, you might see or longer. You can see these two are actually close together. And what it's going to do is, if we've included a single space for or longer, it's going to hold that value. And then further down here, if v or longer is not equal to empty, it's not nil, it's empty, then basically on the data structure, and I've not shown you that part yet, place the value. And this is what the data structure looks like. So this is a programmatically created data structure that contains just enough information to build XML, which represents your Terraform resource. So your Terraform resource is in something called HCL, or HashiCorp configuration language. That generates an XML data structure when Terraform does an apply, which is sent across in a netconf transaction to Junos. And these are all the data fields that can go into the resource for Junos. So what we'll see here is we have enumerated data types. So we have a policy statement, and there'll be a name there. We have a term and a term name there. And in this list as well, we might even have something like address. But these are the enumerated data types. And then we've got from root filter policy statement. And these are all the XML tags on the data structure. And it's this data structure again that's serialized into XML. This is where the key values come from. And if I go all the way to the bottom, now we know what the resource is called. We pulled that from the provider.go, but here it is again. Look, this is the function that's being called by provider.go, but we have Junos policy, options policy, statement term from root. So this is the entry point, and these are all the key value pairs that we have here. So we've got name, we've got name1, which is the term, we've got the policy statement, and then we've got all of these different enumerated types. And these are all root filter types, and you can see these. And then at the bottom, we've got address. So address is the IP address or host name that the root filter uses. So if you've got familiar with building a filter and a policy with terms, hopefully all these keys begin to make sense, and it shouldn't be a surprise now where these keys come from. So clearly we're going to need address. We might use something like longer or longer. That's an enumerated type. We need to turn that on. And then we're going to have name, which is going to be the policy statement, and we've got name1, which is a policy term. So let's get out of this, and I'm just going to jump into the module. But before we do that, actually, we need to just move the Terraform provider. So move Terraform provider into this directory. So .terraformd, plugins, Juniper, providers, Junos, VSRX, 20.32.01.01, Darwin AMD64. Right, I'm just going to do that now, and then I'm just going to go back and do a tree on this Terraform directory. Now, Terraform, again, will look in default locations for providers that exist locally. And this is our provider here. This is what we've just built, and this is the directory that it's residing in. Terraform knows where to look when you identify the providers that you want to use, and this is the version of provider, which is the 20.3R201 build 01. Hopefully that makes sense at this particular point in time. I'm just going to go back up to the module, and then VSRX1, and then Vim. I'm just going to jump into here. So the or longer resource, or the resource containing or longer, is really interesting. So you see now here we have Junos, VSRX policy, options policy, statement term from root, filter address. This is the resource that we've just looked at the source code for. This is something called a Terraform address, so VSRX _3 won't appear in anything to do with Junos configuration. The resource name is the the Juniper configuration group, or the Junos configuration group name. So that will appear in the configuration, but only as the group identifier. Name is the statement name. Name1 is the term. Address is the input prefix, and then or longer is an enumerated type. We use a single space to turn that on. That's how we go from what the configuration is that we want through build a provider, generate some HCL, which Terraform is going to use to build that XML data structure, send it over to Junos. That's how we get the inputs for the providers respectively. So hopefully that makes sense. I'm just going to jump back up now. I'm going to initiate Terraform. So Terraform, or initialize, even if I get my words right. And then I'm going to do a Terraform plan. Now, the interesting thing here is there isn't any local state. Terraform's going to just throw out a plan how it sees fit. What it won't do is it won't connect right now to the device remotely because it doesn't have any local state. And what I mean by that, it's got like an empty brain. It doesn't think there's anything to change or to check for. So think about this in two ways. One, you might have a greenfield, in which case this is not a problem. You might have some basic golden configuration and basic management reachability, so you can use Terraform to configure your device. If it's a brownfield, however, you need to be a little bit more aware, because any configuration we generate through Terraform will be committed as a configuration group. That configuration group will be inherited by Junos, and you might find some conflicting situations where the Terraform configuration collides with what's already there. And also, in the unfortunate circumstance that you've generated a configuration group with a name that already exists on the system, you're going to need to roll that back remotely. Terraform only deals with commit, it does not deal with commit confirm. So we're going to do a Terraform plan. So again, remember at this point in time, there's going to be no remote procedure calls from the Terraform provider over to Junos. So Terraform plan, these are all the things that Terraform thinks that we need to create. It's not going to go and check that remotely. Fine. So now what we're going to do is we're going to do a Terraform apply, and we're going to auto approve. Now, before we do that, I'm just going to make sure there aren't any configuration groups on the device. There are not. We're clear. So Terraform apply, auto approve. Now, all of these resources are being created. One by one, they're being created. Let's just go from top down. We notice the first thing, the destroy commit has been created. Now, nothing happens on the remote instance of Junos here. It only sets local state for the destroy commit. Each of the resources in the modules now, so this is module VSRX1, these will be created. This can take some time. It can take a few minutes just to get each resource created. And the interesting thing is, you can actually see the groups appearing one by one, which is, kind of interesting. And what I tend to do is I match each group name. So we have VSRX underscore, then a number. And what that gives me is an idea of how many groups appear given any one time. And if you have a very large set of resources being deployed, you can kind of see that number grow and grow and grow, which is kind of cool. However, this list is moving pretty quick. We're still doing the module, the contents of the module, and then all of a sudden the module exits and we have the Junos VSRX underscore commit, and it says creating. Now, when this commit rolls out, it's actually a transactional commit against Junos. So all of the configuration groups that have been pushed to Junos are now being committed, and it says creation complete after 5 seconds. Now, when we do a Terraform plan, what it'll do, it'll take local state, and it will do reads against the remote Junos instance and compare the two. And if the remote state is different or the local state is different, it will push the desired state back to the remote state and reset the local state. So think about this as state regulation. You can have situations where both sets of state are different. You can have a situation where the remote's been changed but the local hasn't, or the local's been changed, the remote hasn't. Either way, when you run a Terraform plan, it will tell you what it should be, and it will tell you when you do a Terraform apply what it is. And the nice thing is you can do away with unit tests when you use Terraform for networking, because when a configuration group is created, it's automatically read straight after, and you can have confidence that Terraform has done that for you. Now, good news, no changes. Our infrastructure is up to date, which means all of the configuration groups are here. Fantastic. And if we try and exit out of configuration mode, we should be able to. Imagine if there was an RPC error and that one of the transactions failed. Actually, the commit wouldn't take. So we wouldn't be able to just exit so easily out of configuration mode. So just for the hell of it, what I'm going to do now is I'm going to edit VSRX, edit group, VSRX3. And VSRX3 is our root filter with or longer. So what I'm going to do now, I'm going to basically delete the or longer and replace it with longer. So I'm just going to edit policy options, policy statement, def term T1, show, and I think I still need to edit from and do another show. And I'm going to set root filter, sorry for the many typos, longer. And I'm going to delete root filter 10 or longer. And do another show, top, run a commit. So if you want to think about what would happen if humans and Terraform try and manage the same device, this is a good example. So now we can run a Terraform plan. Again, so what's happening now is there's an RPC is opened up, so a netconf session is opened up to the Junos device. All of the configuration groups are reread one by one and compared with the local state. Now, when we do a Terraform update, there's going to be two interesting things again that happen here. One is we have to think about resources as the smallest possible unit of concern. And the reason for that is when we do an update, the whole configuration group is blown away and it's rebuilt. So if you've only changed one key inside one HCL, but actually what you've got is an absolutely massive configuration group consisting of lots of different resources, Junos will blow away that configuration group and you can end up with a very broken system. So the way to think about Terraform providers for Junos is every resource deals with the smallest constituent part of that. So for instance, if you have a policy with multiple terms, and actually a policy with a from and a to and a then can be three different resources, you can still be referring to the same policy name, and you still might refer to term 1 or T1 in all three resources. And Junos takes care of all of that and builds an inherited configuration, and I'll show you that in a moment. And the other important aspect to this is how we bookended the resources. We have a destroy commit and a top level commit. If we make a change to the contents of a module, so we mess around with one resource, or in this case, we've messed around with the remote system, Terraform's just told us, hey, we have an issue. We've got a drift. So we need to get rid of longer and we need to put back in or longer. Do you think a commit's going to happen? The answer is no. So the commit's already in place. The local state is still the same from a Terraform perspective. Terraform doesn't inherently understand a commit-based transactional system, and by bookending it with commit resources, we've kind of welded the two worlds together. And it's not a perfect weld; it's an imperfect join. The life cycles are just very different. So what we have to do is we have to taint the top level commit to make Terraform reissue a top level commit. So now we've got the plan, we can go Terraform taint, and I'm just going to cheat a little bit here because I don't want to type, but we've got Junos VSRX underscore commit.commit-main. That's a Terraform address for the commit-based resource. And what the taint does, again, it tells Terraform to rerun the create event for that particular resource, and in our case it's the commit resource. Now if I do a Terraform plan, you'll see the commit resource and VSRX3 needs rebuilding. But I don't want to do that. We know what the score is, so Terraform Apply auto approve. And all that's going to happen now is the group will be put back. So if I do shoot groups VSRX3, we might have missed it already. It's still longer. We can actually see this on the data store when it happens. It might take just a couple of moments whilst Terraform itself just goes through the entire list, and it's still right now it's still going through the list of operations that it has. It's refreshing the state for all of it, and again, some of these operations can take a while, especially on larger networks. One of the habits that I've seen actually with people using Terraform, and you can see that the group was actually destroyed there and it's been rebuilt with or longer. So that's when the group disappears and the new group reappears, and then the commit sequence is issued. Where I was going with this, though, it's quite common for a large networking device with lots of different lanes of configuration to be split up into smaller projects. So things like updating a customer-facing port or a customer-facing ACL actually is within the swim lane of the customer's data instead of it being one massive set of Terraform resources. This is a difference really between imperative configuration and declarative. We can keep close customer data for one or more networking devices. We can keep that data close to the customer, and then obviously rerun Terraform for the customer instead of for the whole device. Now then, if I go back to the Terraform screen, we'll see that Junos VSRX commit has been created, creation complete, and we should be back in the familiar situation now where we try and exit. The commit's already happened, obviously it'll tell us that it's not done so. And what we can do is we can do a show configuration, display inheritance with no comments, and what should happen is we get the fully inherited configuration with everything that we've just configured through Terraform. So this is a security address book, and we've got the policies, and you can see here we've got policy default permit. We've also got the policy options, and this is the one really that we were messing around with. So we've got policy options, the import table, term T1 from root filter, then accept, and then term T2 is reject. And if you remember this was one resource. A from resource was one Terraform resource. Term T1 then accept would be another. Term T2 would be another. So 3 resources actually make up one configuration group in this particular instance, and that's the way to divide and divide the problem up. And it means that you've got absolute explicit control over all 3 elements. Programmatically, we're generating Golang code, which generates a provider, and is not as easy as you think in terms of generating just larger data structures. And it shifts the problem of knowing what to create to you, the user. And the idea is with Terraform resources, they should be very easy to build and to maintain. And what we can do now, just to show the end of the experiment, is we can do a Terraform Destroy, auto approve, and then what will happen is each of the resources are slowly destroyed. What I'll do is I'll just do the show groups again here, if I can catch it before it runs out of time. Show groups match VSRX, and what we should be able to see is the groups will disappear. And we're still working on that. And they will all disappear, in theory, all at the same time. In your own time, Terraform. Oh, so there we go. So the groups are now disappearing. So I lied. They're not going to disappear all at the same time. Obviously, this is a candidate configuration that we're looking at. One by one again, so it's going through each particular resource, deleting each configuration, and doing a read as well to make sure it's actually gone at the same time. So it's validating as it goes. Once we get to the last 1 or 2, I'll switch back over to Terraform. We should see the commit, or the destroy commit, and there we go. The module deletion's been dealt with. We now have the Junos VSRX destroy commit that's been issued. 14 destroyed. Now if I go to show groups, there should be nothing. If I go to apply groups, there will also be nothing. So in this short video, we've gone from taking JTAF for a test drive with 1.5 version of Terraform, 1.5 version of the Juniper Terraform automation framework with 0.15.5 of Terraform. We've taken the Terraform module template out of the samples directory. We've actually built a provider using existing sets of XPath expressions. And I'm trying to talk and type at this moment, which is never great. We've taken the existing XPath example file and the contents of that, which is individual XPaths that have been copied out of the respective YANG files file. So in our case, we took the YANG file for route policy. We looked at the XPath expressions, and the XPath example file contains those files, and I'm just going to show you what that looks like. So at the top of this file, these all relate to policy options. Those 4 expressions came out of the text file that represents the XPath version of the yin file. Bit of a mouthful. And from there, we looked at the source code and what resources generated from the policy options file, and that's how we know what keys go into what provider or what blob of HCL. So what keys out of the Go files are representative of what input keys in HCL. Hopefully all this begins to make sense. There's more documentation coming out, there's more diagrams coming out. And certainly in the future, we'll take a configuration and show you how to get from configuration to XPaths, and then obviously from there to HCL. Anyway, this is the launch video for 1.5. I hope this has been informative. Juniper, again, is a HashiCorp Alliances partner. This is great news. And Q1 next year, we'll absolutely see verified providers hitting the Terraform registry. Where you can download the verified providers, or you can just take JTAF for a spin and build your own providers. And again, these are right-sized providers which are targeted for the particular Junos platform that you have, the software version that you have, and just the right contents to allow you to build just the right amount of configuration in your configuration groups. Thank you for bearing with me. I know this is not the most straightforward topic, and I look forward to coming back and delivering another one of these videos.